Hello everyone, and welcome once again to the course on manufacturing methods. So in the previous classes we have already discussed about special casting methods, why these special casting methods are required, and what are various advantages associated with it, and what are the different capabilities and all. Okay, and later on we have seen that under expandable mold casting process also there are a variety of processes involved, like sand casting, which is the most basic one. We have already discussed about all the cell molding, like vacuum molding, similarly expandable polystyrene process, investment casting, also known as the lost wax process, similar plaster molding, ceramic molding, etc. So in the last class about cell molding we have already discussed. So we have seen that basically there are certain advantages of this cell molding. So here the mold in the form of cells, which are very light and thin, and thickness generally varies from 5 mm to 10 mm. And so what basically happens in that particular case, the amount of requirement of the sand which is there, it is very minimal compared to normal sand casting. It is just like 1/20th of the sand which is generally required in the sand casting. Okay, so we have already seen discussed about this. So what basically we have seen is, so there are like initially we'll have the metal pattern which is heated. Okay, and similarly we have after that particular metal pattern, so we already have in the box sand which is mixed with resin and binder, generally 2.5 to 4%, like that. Okay, after that what we do, we just invert it here. So previously it was here just like acting like the lid. Okay, now we invert it so that whatever sand and mixed resin binder was there, it falls directly on this particular surface and conform to that particular heated surface. As this surface is heated, so along with the resin and binder, that a layer of sand it gets deposited here. After that we once again invert it, and now we have the cell here, which is a thin layer. Okay, after that we do the baking. Okay, heating, and during that curing happens. After that we take it out the strip, the mold. Okay, and we have already said that basically two halves we make. Okay, it's two identical halves we have. Okay, and similar is the process we'll be following, and after that we just clamp them, or whatever is the way you want to join them, and we basically get the final required whatever is this particular mold. And once the mold is being obtained, which is the cell mold, okay, after that rest is somewhat similar. The molten metal will pour here and we'll let it solidify, and as it is expandable mold process, we'll just break it, maybe by using hammer or Thor's hammer or whatever. Okay, and after that, once that is being done, what will happen, so whatever metal has solidified here, we are going to get that kind of cast product. So that is the thing. So now today we are like the advantage, disadvantage we already know. Smoother cavity, it is there. Okay, smooth cavity surfaces machining generally is not required. Okay, so mass production, for mass production it can be mechanized, but as we are talking about metal pattern, so sometimes it is expensive and not that much suitable for small quantity, and sometimes formation of voids in the cell and peeling back that occurs. So those are difficulties that we have to say. Now today we are going to basically discuss about the investment casting. So now once again it is also is a expandable mold process only. So it is expandable mold process. Now here the pattern is made of wax. Okay, and after that it is coated with refractory material. So this is important. Pattern is made of wax coated with refractory material to make the mold. Okay, and after that what we do, the wax is melted away prior to pouring the molten metal. Okay, and that is the main basic thing once. And this investment, why the name is investment, basically investment, it meaning is to cover completely, which refers to the coating of the refractory material around the wax pattern. So it is made of, pattern is made of wax. Okay, and what you must remember is it's a very precision casting process, very intrinsic details, all those even whatever in the medals etc, or whatever we can say emblem kind of thing you see, those kind of things also can be even in this particular investment casting, because the whatever is the pattern that is there, it is made basically of wax. okay, and it's and on the wax giving different details is comparatively easy. Even by using sharp edges, knife, etc., also you can even give, you can some decoration, etc., can be done, and whatever that way you can obtain the intrinsic details. Okay, so what are the various steps involved? So initially we make the wax pattern. Okay, we will show with respect to this particular figure. So figure A, you can see some wax pattern is being made. Okay, and then what we do, several patterns are attached to a sprue to form a pattern tree. So now here, so this kind of pattern, this they are on this particular sprue, several of them are attached, okay, and this forms a kind of wax pattern tree. Okay, this is a pattern tree. Next, what we do, the pattern tree is coated with a thin layer of refractory material. Okay, so now what we'll do, we'll have the refractory material, okay, in a slurry kind of thing. So the whole pattern tree will take, okay, and here we have the refractory material, okay, and what we'll do, maybe by robotic action or by hand holding or whatever, depending on the sophistication level of the lab, we are going to, you can say, dip it inside the slurry kind of refractory material. Okay, it's kind of somewhat liquid kind of thing, and we'll coat the whole sprue. Okay, next, the full mold is formed by covering the coated tree with sufficient refractory material to make it rigid. So generally in between these steps are sometimes repeated, okay, and in between sometimes once again a coating is being made, okay, and we'll let it solidify, and a particular layer which is sufficient to withstand the whatever is the load, etc. Okay, so that is being made. Okay, next, the mold is then held in an inverted position and it is heated to melt the wax and permit it to drip out from the cavity. So now once that particular coating is being over, okay, totally coating, then we make the sufficient coating. Okay, so this brown color, it is nothing but kind of the coating, and this blue colored, or you can say the same blue is shown here, so they are the pattern which is made of what, which is made of the wax, and whatever is the details that you want to give on that wax pattern you can give, and depending on what kind of details is there on the surface of the pattern, wax pattern, so that way only when we are dipping it inside the refractory material, so basically that kind of shape or that kind of intrinsic details will be transferred here. Okay, so now what we will do, we are going to, so we are going to now invert it. Okay, we are going to make it upside down. Okay, and after that we are going to heat it. Now what will happen inside of this particular refractory material, okay, this layer is, brown layer is made of refractory material, so it can withstand that particular heat. Okay, there will not be any problem with it, but what will basically happen is inside of it we have the wax pattern, and once it is heated the wax will melt. Okay, wax will melt and it will drip out from this particular, okay, and the once the properly it is being dripped out, okay, the whole wax is being dripped out, what will happen, this way the white is nothing but it is kind of the, that is, it shows the cavity. Okay, so now the inside is kind of hollow, correct, that means we have obtained our mold. And on the surfaces, what is there on the surfaces, whatever is was the details it was there on the wax pattern, that kind of details has already been adhered to. Okay, now once it is being sufficiently properly dripped out, then what we'll do, now the mold is preheated to a high temperature which ensures that all contaminants are eliminated from the mold. Okay, it also permits the liquid metal to flow more easily into the detailed cavity. The molten metal is poured and it gets solidified. Okay, so already it is being preheated so that all those contamination, etc., it is being, it's not there. Okay, it is being preheated and all, and after that it is, this is what, this is the tree, mold tree, okay, or the sprue. Okay, or there is a number of patterns are already there, was already there on the sprue. Okay, it has acted like a kind of a tree. Okay, and now the molten metal, whatever is the way, we are going to pour on it, and through this particular screw it will run through it. Okay, and fill up all the cavities and all, and once that is being done, all the cavities are being filled up, that is the mold cavity, and it gets solidified. What will happen, basically we have obtained our whatever the product. Okay, and after that, as it is expandable mold process, we are going to use the horse hammer. Okay, or we can use vibration or any other means. Okay, and we are going to break it down, and once we break it down, so we'll obtain this different cast part. Okay, and after that, depending on, like, we'll be separating it out from that particular tree, we'll slice it. Okay, we are going to trim it, and single we can say all that particular whatever is the cast part we are going to obtain. Okay, and the last step is the mold is broken away from the finished casting, and the parts are separated from the sprue. Okay, so this is about investment casting. But you must remember, it's a very precision casting process. Pattern is made of wax. As it is made of wax, giving details on the surface is very easy. After that, we coat it with refractory material. Sufficient coating is being done. Okay, number of layers we can have. Okay, and we generally sometimes it is being air dried, or sometimes it is etc. But after that, we get that particular concept, the tree. Okay, and after that we invert it and heat it, so that all the wax it melts and it gets out, it rips out. And after that, it is being already been preheated, so that there is no contamination. We just like we have obtained the mold. Okay, a number of molds are there on that particular tree, and we allow the molten metal to fill in and let it solidify, and after that we break it and take out that particular wax, that particular cast tree. Okay, and after that we can take out the separate individual cast product. So this is basically about investment casting. So some of the advantages and disadvantages. So advantages, so the parts of great complexity and very intricate details, it can be very easily cast. Dimensional tolerance, cost controlling is very you can control it properly, and surface finish is very good. And this whatever wax we are saying, that we have basically stripped it out by heating, so that same wax it can be reused for making other patterns. So basically there is that wax loss is not there. So additional machining is generally not required. It's a net safe process. Some of the disadvantages, so a number of processing steps are involved, and sometimes it is comparatively expensive than normal sand casting, etc. Next, we'll come to this permanent mold casting process. So whatever we have previously discussed, like this self molding, sand casting, okay, uh, similarly this investment casting, these are kind of expandable mold process. That means we at the final stage we break the mold so as to take the cast product. Okay, now we're talking about permanent mold casting process. So we already know that if we have to break the mold each and every time to get the final product, in case of our expandable mold process, so economically it's not that much good. Each time, every time we require a new, you can say, new mold. Okay, now but this particular problem is nullified in case of permanent mold casting. In permanent mold casting, what happens? The mold is reused many times. It generally uses a metal mold constructed of two sections, which designed for easy and precise opening and for closing purpose. See why this opening and closing that is required, because we are talking about permanent mold, and we are talking about, that means we are not going to break the mold, but we are going to reuse it, okay, again and again. So if we are not going to break it, so there has to be some provision to open it, so that we will be able to take out our cast product after it has properly solidified. Okay, that's why generally two sections are made for easy and precise opening as well as closing. So the processes includes basic permanent mold casting. We also have die casting. Similarly, centrifugal casting also is a important type of permanent mold casting. So one thing you can remember, like you should know, is which the mold used for casting lower melting point alloys are generally made of steel or cast iron, And for higher you can say mold used for casting steel, it is generally made of refractory material due to the very high pouring temperatures involved. Okay, so sometimes in competitive exam this is being asked. So what are the basic steps involved in permanent mold casting? In general, what basically happens, as we have already discussed, so there will be two halves for that particular mold. Okay, in most of the cases one is the kind of fixed half, one half is fixed and another half is movable, and generally some hydraulic system is generally allowed, okay, so as to have the movement, that means ultimately opening or closing. So this particular mold section is stationary one. Okay, this particular section which is fitted with hydraulic system is generally the movable mold section. Okay, so whatever is the kind of mold cavity that will require, okay, or sometimes in our cases maybe we can also use the word die here. Okay, so in that particular case, whatever is the shape that will be required, based on that we have to give that particular details on the two surface. Okay, we have to see how it is going to conform, how it is going to match. Okay, based on that whatever is the shape that will be given. So now in general what is basically is done is the mold is preheated and a coating is given. Okay, by spray coating is generally done so as to there are two functions, basic two functions you can say. One is it allows the movement of the, or you can say the proper flow of the molten metal, it allows it. Okay, similarly while taking out that particular molten metal, not the molten metal, solidified cast from that particular whatever is the particular process, okay, depending on what type of permanent mold casting you are talking about, so it facilitates easy removal of the particular solidified cast. Okay, otherwise if there is suppose some contamination on that particular phase, basically by this particular coating, spray coating, the face become the die phase, or ultimately you can say the mold phase. Okay, the two halves it becomes very, you can say, polished kind of things, or the coating gives you can say the minimizes the all those roughnesses, etc. Okay, and it facilitates for easy movement or easy flow of the metal also, and easy removal of the particular cast product also. And after that, once that is being done and everything is being set up, depending on your requirement, sometimes we may have to use the core so as to give some internal structure, internal shape, hollow shape, etc, whatever. And after that, by using this hydraulic press, we basically close it. And while closing, depending on what kind of design, you wanted on the particular cast, based on that basically this kind of this white portion is nothing but the hollow, it is for acting like the mold. Okay, based on that it will be there. Okay, and after that rest is somewhat similar. So once again we are again going to pour the molten metal. Okay, and it is going to completely fill that particular whatever is the mold cavity we had, and we'll let it solidify. In between we have to let it solidify definitely. Okay, and after that by using the arrangement for opening that particular mold, okay, one part will be stationary half will remain there. So this is the stationary half, it is already shown. The stationary half, it will remain on its position, and movable half will open. Okay, and after that we'll just take out this particular part. Okay, and that completes that particular process. And once again, this, as we have not broken that particular base and this particular two halves of the mold, so this we can reuse for the next purpose. Okay, so that's why it is kind of permanent mold casting. I hope you have understood. So some of the advantages and limitations of permanent mold casting. Generally the advantage includes good surface finish, because we already do the coating, etc, I have already discussed. So all those roughness, etc is minimized, so the surface finish will be better, that means minimal roughness. Dimension tolerance control, close dimensional control, it is also possible. And more rapid solidification caused by the cold metal mold, it results in a finer grade structure, so stronger casting are produced. So see, if, as we are talking about permanent mold, generally these molds are made of metal only, and metal it acts like somewhat acts like the steel that we have discussed in case of casting. So rapid heat extraction is there. Okay, and because of that finer grain structure it is being produced, finer grain structure also results in stronger casting. Okay, because voids etc. it is minimized. Similarly, limitations, it is generally limited to metals of lower melting point, because if you are talking about very high melting point metal, then there will be certain disadvantages like oxidation. Maybe there it can tear off that particular, you can say, some tearing off may happen on the surface of the mold, and once the that particular mold, permanent mold, is somewhat damaged, so basically it's useless, because in the next run it is not going to give you proper product, and already it was made up of metal, so difficulties are there. Similarly, simple part geometries compared to sand casting, because we have to give the opening and closing provision. That's why we cannot go for very intrinsic details and all, but we generally go for some simple geometries which can be very easily made in two halves. Okay, and cost of mold is definitely, you can say, made of metal and all, and we have to make depending on what is the alloy or alloy system or metal, pure metal we are working on. Based on that, proper choosing of the mold metal also we have to done. Okay, similarly, unlike expandable molds, these permanent molds do not collapse, so the mold must be opened before appreciable cooling contraction occurs in order to prevent cracks from developing in the casting. Okay, so this is one of the important thing that you must know. So application of some permanent mold casting. So due to high mold cost, it processes best suited for high volume production, and very easily it can be automated. You have already seen like hydraulic system etc. can be done. Opening closing can be automated. Pouring of the molten metal is generally automated. Okay, and monitoring, proper monitoring, conditional monitoring may be done, and when required it can be taken out. Okay, generally automotive pistons, pump bodies, certain other parts from aircraft, missile, etc. are cast in permanent mold. Okay, generally most common metals cast are like aluminum, magnesium, copper based alloys, and cast iron. So in the next class, next video, we'll be discussing in die casting or pressure die casting. Okay, under that we'll be basically discussing about hot chamber die casting as well as cold chamber die casting. Okay, so thank you.